Welcome back to Ian Hardware. Have you ever faced this issue? When machining a rigid workpiece, poor surface quality occurs due to vibration? If this happens to you, how would you resolve it? Today, we're going to share solutions for eliminating vibrations even when the workpiece has good rigidity. Subscribe to our channel, and let's get started. There are 4 main causes of vibration during machining. If I've missed any, feel free to add them in the comments. 1. Insufficient clamping force from the fixture. 2. Lack of rigidity in the tool or tool holder. 3. Inadequate pressure applied to the tool. 4. Insufficient rigidity in the machine tool. Now let's discuss how to address these issues. First, when cutting, ensure the workpiece is securely fixed by choosing high rigidity fixtures like those with serrated jaws. These will lock the workpiece firmly at both ends, preventing any movement during cutting. But what if you don't have serrated jaws or the fixture lacks rigidity? In that case, you can reduce the spindle speed to minimize vibration during cutting, increase the feed rate to boost cutting force and tool stability, and decrease the depth of cut to reduce the contact area between the tool and workpiece, thus lowering the cutting force. Next, selecting the right high rigidity tools and high performance tool holders while properly controlling the tool overhang length can significantly reduce vibration during machining. I won't go into too much detail here, but if you want to learn more CNC knowledge, check out my other videos. Additionally, tools require a certain amount of pressure to counterbalance resonance and stabilize during cutting. Without sufficient tool pressure, the tool may rebound or vibrate during cutting, leading to chatter. To prevent this, you can lower the spindle speed and maintain the feed rate to increase tool pressure, although this will increase the cutting load. Alternatively, try increasing the feed rate without changing the cutting speed to enhance chip thickness per tooth, increasing tool pressure, stabilizing the cutting process, and reducing vibration. When machining, leaving an appropriate allowance can effectively improve the surface finish of the product. If you've already applied all these techniques and still experience vibration during machining, it may be due to poor machine performance or low machine rigidity. Generally, for heavy cutting, opt for a high torque spindle and a boxweight machine. The machine's structure is also crucial. For machines of the same size, rigidity decreases in the following order: double column structure, gantry structure, horizontal C-type structure, and vertical C-type structure. To summarize, when a rigid workpiece still exhibits vibration during machining, consider factors such as fixtures, tool holders, tools, cutting parameters, and machine performance. Optimize each factor sequentially to eliminate vibration. Subscribe to our channel to easily learn CNC knowledge and make a little progress every day.